forgotten about them. So yeah, no, I can't remember if I saw the JCB one down there, but yeah, Bonneville was an absolute experience. And anyone that's whether they're a petrolhead or into electric stuff, if there's not a foot of water, flooding the whole place, it's definitely a car enthusiast must to go and visit. There's still a few things to tick off my list.
Yeah, I mean, you don't get that scale here in the UK of variety and just the money that some of these guys have to spend on some of these vehicles. Independent, rich, individuals. Yeah, it's fascinating to walk around it and speak to some of them. Yeah.
Yeah.
A lot of the stuff is actually still very homemade. A lot of it's still very home kind of made, if you like.
We wanted to take the rental. We wanted to take the rental vehicle up, but unfortunately, it didn't fit into any categories. But yeah, like you said, there are a lot of categories. We saw some really interesting things there. I've got a load of pictures, and
that's what I mean. If you hire your car from Salt Lake City, if you hired your car there and return it there over the Bonneville week, they will check for salt underneath your car. So that's why loads of people go to Wendover and get their car washed straight after they've come off Bonneville. That's what. Obviously, it also stops your car from rusting. But
absolutely.
The hire car companies do check to see if you've attempted some sort of speed record with a 300C Chrysler or something,
No, I think we rented ours in Denver when we flew in, and then we had our journey all the way to Bonneville, Salt Lake City, then Bonneville, and then back, going past, going up the Pikes Peak, which is very exciting. Very exciting stuff. So, right. We are live. Here we are for another Chargeheads live, and very exciting. And a big thank you to Joseph Holdsworth coming on today, because we're going to be talking about a piece of equipment which is called CellGuard. And I'm really looking forward to finding out more about it, because safety in batteries. It's great to know that there are these things coming into the EV world to help the electric transition, make it safer. So I've got a load of questions for Joe, and I'm hoping anyone that joins, has got a few questions as well. And any questions at the end, once we finish the live, pop them on there, and I'll do my best to answer them where I can. Thanks for everyone who's joined so far. Hi, Jerome. Hi, Lars. Zoe, Foxhound Follies. Thanks for all coming straight away. American debt is very high, though. Maybe I should get a loan. Well, I'm not sure if a bank would be approving of a loan for a Bonneville race car, but you've got to try it. If you don't ask, you don't get. But yeah, just as a bit of a intro, my name's Tim Aylan. I'm founder of Chargeheads. Chargeheads Live is something I've started at 8 o'clock every Thursday, talking about everything to do with EVs, focusing on modified EVs, EV conversions, and everything in between. And Joe, can you tell us a little bit about how you've got to this point in terms of producing this CellGuard piece of equipment for safety, and a little bit? Obviously, we were talking about Bonneville earlier because of your association with Bloodhound. So can you give us a little bit of a sort of a backstory, and then we can get on to the exciting stuff.
I'll try and make it brief, but I guess it started with my dad, who went to see Thrust SSC actually run it in the desert. Now, that wasn't Bonneville.
No.
And he was a member of Bloodhound's 1K club, which was like whoever was interested in it could go to talks on it. And I went with him on a talk to it, and I handed in my CV and ended up getting a job there, which was, it's been one of the highlights of my working career, I suppose. It was great fun. Maybe will be great fun. They're looking for funding again, aren't they? Looking to get a new driver for it.
Yeah.
And because that project, by its nature, is always in and out of money, you end up working on lots of other things. So I was a contractor at the time. I worked for Williams, but indirectly for JLR. They did a one-make race series called E-Trophy, which was based on the electric, the I-Pace. So I did the vehicle control module. Yeah, I did the vehicle control module for that. And I then went on to work on an airspeed record, an electric airspeed record called Project Excel, which actually has the airspeed record, and you can see it in the Science Museum now. I have done all sorts of other stuff as well, but I guess during this process of working on lots of these different projects, my background, which is electronics, software, firmware, that kind of thing, systems, you end up noticing you are looking for sensors and things to fulfill a function on these vehicles. A lot of it, particularly on the small projects, you end up designing them yourself or doing stuff yourself because they don't exist. So I thought, okay, well, why don't I start making my own CAN-based sensors for targeting low volume R&D applications? So the first things we started doing were inertial-based sensors. So that's looking at vehicle dynamics and things like that. And one of them was targeting battery safety. So that was looking at detecting early stages of something called thermal runaway, which is where your cells get really, really hot and catch fire. Yeah, and that got sold into the aircraft project because, as you can appreciate, it's not quite like a car. The safety case is a lot. Well, how would you put it? I mean, you can stop a car and get out. With a plane, if there's a problem, you've got at least 10 minutes, before you can get it on the ground. So any kind of early warning system that you can get is beneficial. So those were the first guys to kind of use it. And then I thought, I suppose, hang on a sec, this is probably not the only situation where it's needed. Then I start to try and sell it, push it a bit more into more markets. And an OEM came and asked us if we could do a mass-produced version of it, which is what CellGuard is. So yeah, and I guess it's still kind of early days. It still seems like a new kind of concept or technology into batteries, but yeah, we're seeing a lot of pickup in terms of at least OEMs wanting to test it. So yeah, that's where it's come from.
Nice. With all of the, obviously there's a lot of negative press with regards to batteries. So having early detection is great. And as Zoe's put in there, there's no hard shoulder at 30,000 feet for aircrafts, of course.
Yeah.
But yeah. Oh,
yeah, I mean,
someone says they've got no sound. Oh, Jamie, yeah, I think everyone else has got sound. Please put in the comments if you haven't got the sound. And Paul was asking why I'm a bit softer on the focus. It's because my other laptop's not come back from the shop yet. So you're gonna have to deal with the less pixelated Tim. And for now, I'm afraid, Paul. But yeah, so obviously you've got this. You've got the skills to be able to to design these sensors. And what from a battery point of view, obviously there are a lot of different chemistries of batteries, and something that I was thinking is I think it's a great sensor to have for sure. Whether is it a retrofit style bit of equipment, or does it have to be how's it implemented, the actual
so
the equipment?
We're trying to get it in. We're trying to get it in at the design phase because it's meant to fit inside battery packs. That's where it's going to work. We'll have the best response time, better performance. So yeah, we're trying to get it in at the design phases for, I suppose, the next generation packs. Yeah.
Yeah. So have they got anything at the moment? Is there any kind of?
Yeah. So what they do at the moment is so you got your battery pack, and the electronics that comes with it will measure cell voltage and cell temperatures. And they will use those two bits of data to try and detect problems. The issue with using cell voltage is is that imagine you've got a load of cells in parallel, and one of those cells goes bad. Well, all the other cells will kind of mask that bad cell. So it's actually quite hard, particularly in a short time frame, to spot that you've got a problem with a cell from cell voltage fluctuations. Over a longer period of data, you could say, okay, that series array of cells looks suspect. But short term, it's difficult. The temperature method is actually good. It's a good way to check, if you've got a problem with the cell, because it's checking to see if the cell gets hot, which is what the problem kind of originates from. But the issue with that is that the providers of chipsets into these packs, what they do is they'll have a channel to measure cell voltage and then one channel to measure temperatures. But that means they'll only ever cover like one cell in a whole parallel bank of cells. What that equates to is, at best, you are measuring only 50% of the cell's temperature, and usually it's a lot less than that. So that leaves you open to just not being able to detect a cell getting hot, because chances are is you're not actually measuring the cell that's getting hot. So that is what they currently do. That's where this kind of comes in, because this is a non-contact sensor and it looks for the gases emitted from the cells if there's an issue with them. So you can use that alongside current battery management systems to detect issues early, essentially, before you go into something called thermal runaway. So yeah, that's what they do now, and that's where this kind of technology fits in. Yeah.
And how many battery management systems does it talk to? Does it talk to the majority of them? Are there any that you're still trying to work out still? Or?
So typically still CAN bus is widely used on these vehicles. CAN bus.
Sorry, could you say again, Joe? I missed that last bit. Sorry, say again.
So on modern vehicles, you have something called CAN bus. There are other, which is a digital bus, which is a communications bus that sensors will talk over. So our sensor is a CAN-based sensor. And the nice thing about that is it makes it very easy to just add it on to any CAN bus. So in terms of integration with other battery management systems, it's pretty simple, really. If you're in that field and you're working with CAN bus, it's quite easy to do. And the sensor itself is configurable, so you can change what's known as the CAN address, so that you don't clash with other units on the CAN bus, and also you can change the CAN speed so that you can make sure it matches the CAN speed of the network it's attached to. So yeah, integrating is pretty simple into any.
So it detects the gas. Is there any? Perfect. You said it detects the gas. Does it detect the potential thermal runaway in any other way, or is it literally just the gas?
So the sensor there's two variants, but the main variant has got a sensor which detects the gas. It's also got a pressure sensor. So as you see gas released in a pack, you'll see an increase in pressure. But the sensor's not just for like this. A thermal event or a cell venting is kind of a one-way trip with a battery pack. After that's occurred, your battery pack's probably going to either be very expensive to repair or it needs to go in the bin. So this sensor just doesn't just do that one-shot, one-off kind of detection. It's got a humidity sensor on it, so it can check for water ingress. It's got a dew point sensor on it. That's useful if you're cooling the pack. So a lot of performance vehicles will actually cool their battery packs. If you cool the cells down too far, you can actually hit dew point and start forming moisture on the cells. So this sensor tells you that. The other thing it measures in one of the variants is impacts. So it's got an accelerometer specifically designed to detect collisions and to see if you've over-G'd the pack. So, a lot of the situations now is like someone's parked their car at the side of the road, someone goes into you, you're like, well, at the moment, I think they just use the airbag to go, oh yeah, that's a write-off or not. But an airbag has not got the fidelity in terms of the G range it measures, and also duration of the G and etc. and whatever the crash case might be. This sensor specifically targets that and specifically aims to tell you whether or not the crash has damaged your battery or not. So it's got that feature too.
Okay, well, Lars, who we had on, I think it was last week now, was saying that he seems to think that could have saved his battery pack because he had a battery fire on his EV conversion. So yeah, I think, you know, having that from a safety point of view, it's ultimately it's going to save lives, isn't it? Giving you all that extra time to be able to contact emergency services.
Yeah, I mean, there's a lot of focus. I think the legislation's coming in now, particularly for public transport, which is you need to be able to detect and contain a fire for X amount of time in order to get people off the vehicle. So any kind of early warning you can get allows that to happen, and that's one of the things this sensor can get you. But yeah, I mean, as mentioned, people focus in on the thermal event because I guess that's the flames and the exciting bit, but the sensor also does lots of other useful things as well. So yeah, it might have saved the pack. I don't know. I mean, it depends on what the failure mechanism is, but yeah.
One of the comments here by Fox and Follies saying, so if any one cell in a module begins gassing, you would know immediately. Is that the case? I mean, how quickly does it detect it?
So, I mean, the response time's dependent on the kind of free air volume that's inside the pack, but you are looking at a very rapid response, probably under 10 seconds, usually under 5.
Okay, that's good. I've got a few more. Lars, what intervention is still possible when gases emerge?
Yeah, that's a good question.
Probably get out of the car.
Yeah, I mean, the other thing you don't want to do is have false positives as well. You know, OEMs don't want to have, you know, a false alert and then everyone gets out of the car. And so there's a trade-off between how certain you are there's a vent and how quickly you respond to a sign that there's a vent. So there's those things going on in the background. But to answer your question, what can you do if you detect a vent? Well, it depends on the failure mode inside the cell. So let's say you detect an event. The reason why your cells are getting hot is because you've probably got them under load, i.e. the car is driving. So you would disconnect the bus bars or disconnect the H3 pack from the rest of the car. That would then give you a good chance of not then proceeding into getting the battery hotter and it turning into a thermal event. However, you know, it's a good question. You can't always guarantee what the failure mechanism has been inside the cell. Most of the time, if you unload the pack in from our testing, you're going to be okay, but not necessarily every time. So the best thing to do is, get out of the vehicle at that point. Yeah, I would say. Yeah.
Well, it sounds like you've got an order ready. Lars has asked where he can get one. So,
so we got,
you know, I think if you do get, well, let's lead it on from there. You know, are these available now, and where do we get them from? And obviously, we'll go back to where we were before. But
yeah, so there's a company called Felton in the UK that we use as a distributor.
I think we've heard of them.
Yeah, and the others distributors actually, what we're doing, you know, we're still early days for us, and we're learning about distribution as well. So we've set up distributors that actually target OEMs rather than the general public, because that's where I guess we see the volume sales in this. But Felton is a company you can buy it from, and it is something we would like to kind of build on. But our main focus at the moment has been distribution into OEM. Yeah.
Okay. And whereabouts are they made? Are they made in the UK? I mean, where are the components sourced from?
Yeah, so like most supply chains, the components are made by multiple companies. Some are European. The actual integration or assembly of them at the moment are in China, but we might move that depending on our customers, what they want. The final build, integration, programming, test, calibration happens here in the UK. Yeah.
Okay. And I mean, it's something because if you didn't know, Joe, myself and mainly Ralph Hosier from RHEL Engineering, we're building an electric TVR. And
A TVR.
like
Okay.
very
Do
few
you think it's going to be
TVRs,
more reliable? Do you think it's going to be more
it's going to
reliable now?
more reliable, safer. You know, we're trying to make it as safe as possible. So this could be a really good addition. But yeah, what's the cost on the cell guard? What are they retailing at from, for example, Felton?
So I think from Felton they're about £77 to start with in one. If you buy,
£77.
yeah. So if you I think with OEMs and stuff like that, I mean obviously that's one or twos, but the volume the cost comes down substantially in volume. But yeah. Just to go back to the TVR thing, my
Wow.
dad has a TVR, so it's okay for me to say that about TVRs because it was always having problems. Great car, always having problems.
It's all right. You're
Yeah.
among friends here, Joe. It's fine. You know, we all know what TVRs are like. Well, yeah, because I had a Griffith 500 for 7 years. So,
Did you?
but yeah, the car that we're converting is a 350i. And we're using used batteries to make it as green as possible. So, for the sake of £77, to give myself more, you know, I think you could argue from an insurance point of view, that could be an insurance standard. And I know that there's a lot of work being done by people in the EV conversion industry, and you know the enthusiasts. And I'm trying to help that by bringing more EV conversion enthusiasts together by having these sort of standards. And I think this could be it's a really good case to have this in every conversion from a safety point of view and to give people that extra time. But going over to the question, okay. It's a bit of something about batteries there. I'll come back to that later. But no, that is really interesting. I'm actually surprised at the cost. It just seems great value from what it actually provides from a safety point of view. So, funnily enough, we've got Chris on from Felton next week. So I can always put my order in next week, Joe. And I'm sure the guys listening today will be very keen to know more about it. You'd want to get one per battery enclosure, so you'll need 2 or 3 for the TVR. That is true. I would need 2 because there's 2 battery boxes, funnily enough.
What's the capacity?
Is there any?
What's the capacity of this?
It's 40 kilowatt hours. 40
is
kilowatt
that
hours.
Total? Is it?
2 battery packs. Yeah, that's total. Usable is going to be about 38. So yeah, it'll be exciting. We're not far off. We're not far off.
Are you making all of the battery enclosure yourself? And is that?
Ralph is doing all the battery packs. Yeah, it's exciting stuff. I'm hoping to do the course soon, level 1 to 4, and then do the EV conversion course when I've got time and some money to start getting involved in it myself. Because I used to be at the point where I'd look at a car and think about what could I do to make it more exciting. Now I look at cars and think, where would I put the batteries and motor? So I think I'm really involved and really kind of passionate about the EV conversion side of things. So there we go. So Lars has put here, my cell failure. So this is the Lars we talked about earlier, caused by an internal cell short when the car was parked. So yeah, there we go. Can the sensor wake the car up if it measures an event? Oh, that's a good question.
Yes. So the sensor has a low power mode that turns it off on CAN, and if it detects a threshold being breached, it will turn itself on and then can wake up the other CAN modules from itself. So yeah, it does. Yeah. It's also got.
And
It's also got. It's also got. It's also got memory or storage on it, so it can remember over power cycles whether or not a threshold has been breached, which might be useful, more useful for humidity or dew point or temperature parameters. But yeah, you can see if your pack's got hot or whatever, or had an impact. For example, in the impact case, it will save. It will save the flag or flag that there's been an impact and save it to its own memory, so that when you power cycle it, it's still there. If you see what I mean. So obviously, if you powered cycled it and the fault cleared, it's not that useful.
Is there a way of plugging in and downloading the data to have a look at a bit more detail?
So at the moment, the data is literally a flag to say it's over this amount or under this amount or whatever. So you can look at it immediately that way. The reason why I guess we didn't want to start recording data on the actual device is because it gets expensive to do that. And also there's other problems with doing that. Let's say the power's cut and you're trying to write to it, it can damage the memory, etc. So flags are the easiest way to get around that, basically. Yeah.
Okay. And is there any development? Have you got a oh, sorry, hang on. Sorry, we've got a new puppy, and it just ran in, and luckily my family members grabbed it. It's the madhouse we've got here. So we've got a new puppy, and it's mad as a bag of frogs. It's what is it? It's not a cockapoo. It's a lab. It's a labradoodle. That's what it is. And, yeah, it's a bit mad. So yeah, it's a bit mad. Name's Rebel by name, Rebel by nature, but it's gone now, so we're all good. So only wake on CAN or also analog?
It's got a digital pin as well. So it can also drive. So it's got 5 pins: power, ground, the 2 CAN lines, and the 5th pin is a switch. So the switch can be turned. So you can program that switch to come on at a certain threshold. So if by means of analog, I mean, I suppose you might mean analog output in terms of the sensor values. It doesn't have that, but it does have a digital I/O that you can set to trigger based on a threshold. So you can use that to turn something on as well.
Okay. Well, yeah, no, that's really good. And in terms of the actual cell guard itself, are you working on a Mark II, or are you onto another sensor from a safety point of view? What's kind of next? Because I mean, from the information wise, that ticks so many boxes for me. So I didn't know that I wanted one until now we've got all the information. I definitely want a couple. So I'm going to certainly put an order.
They only come in black. Okay.
You're going to say 400, aren't you?
But there's lots of stuff I'm working on. Yes, there are. I've got other ideas around this. I think we talk about £77 for an OEM. That is quite a lot, actually. So I want to develop a cheaper version of it, less features, things like that. There's other things that are in the pipeline that are not these types of sensors. I do inertial sensors and dead reckoning. Have you heard of dead reckoning? So it's where it
does ring a bell.
Yeah, sure. It's where you lose GPS, but you can still get your position. So it's useful if you're in inner city areas, because GPS signal, you can suffer from something called multipath, which could make your position jump around a lot, and it'll work through tunnels and car parks and stuff like that. So I'm working on something, or a CAN module that supplies that to the car. So it's useful for position and things like that. lots of a CAN A to D, an analog to digital CAN converter, but this one's slightly special because it's got an ultra low power mode, which means that you can turn the car on from it if something goes beyond a certain temperature or value, or there's a button press or something like that. So lots of things really, but yeah, in this space, which is the EV battery space, yeah, there are future variants. It's like anything though, you have to kind of, although I've got all these things I want to do, you've kind of got to deliver one thing at a time, hopefully make some money from it, and then use that to work on the rest of the ideas you've got. So yeah, there is more, but yeah, the focus is this one at the moment. Yeah.
Foxhound Follies has asked a very relevant question, which is, what's the physical size of the sensor? I mean, we've actually got, if I just present for a second.
Yeah, I might have one, like a prototype one in this room. Hang on. I've got one of the early prototypes here in my hand. This is one of the early types.
There we go. Hopefully you can see this. There we go. That's what it looks like there. And yeah, if you could show us what it looks like. There we go.
So
okay, yeah. So
it's pretty small.
It's not huge. It's quite slim, isn't it?
Yeah, it's about 10 mil high. So
is it the size of a debit card, credit card?
Yeah, I've got. Let's just see if I can get a debit card out and you can see the size comparison. So that's
does it need to be mounted on anything in particular?
So that's the.
Oh wow, yeah.
So it's pretty small.
Yeah.
It's pretty light if you're worried about weight. It's 15 grams. Yeah.
Okay.
What was the other question you just asked me?
Is there a particular way to mount it? Does it need to be mounted a particular way, or is it fine to be mounted in any which way?
So I guess a couple of things. We say usually these packs have a breather port on them somewhere. So mount it near the breather port and mount it somewhere. If you did get liquid in your pack, although probably at that stage it's the least of your worries, whether this sensor is getting wet or not. Mount this slightly, above that point, so near the breather port, away from where moisture or water will pool. That's basically it.
Okay. Lars has asked, does it have any certifications?
Yeah.
CE,
so
ECR, R10.
So it's been tested to automotive standards, ISO automotive standards. So when I say that, it's gone through the electrical testing, so the EMC testing. What that tests for is voltage fluctuations from maybe alternators on hybrids, which can be quite severe. It's also gone through environmental testing, automotive standard environmental testing. So yes, I mean, we're trying to sell it into OEMs, which means that it has to have passed these things essentially. So yeah, it has.
Okay, and have you got any OEMs on the hook at the moment, or is that NDA?
Yeah. I mean, I can't. Have you got... I mean, yes, we do. I can't mention the names, and that makes it sound, But yeah,
it's good. It's good. It is good.
Yeah, I mean,
and have you got anything that you want to put it in?
Say again?
Go on, sorry, there's a delay.
Yeah, no, I mean, I think I answered the question. Yeah, there are OEMs that are going through the process of taking us through their procurement chain now, which is quite, impressive. Good. I mean, as in the procurement chain itself, the number of hoops you have to jump through is quite large. But yeah,
I can imagine. I can imagine. And Jamie's put +1 on ISO monitoring. I'm not sure what that is, but I'm not sure if you can answer that.
What's that one, sorry?
+1 on ISO monitoring. I'm not sure what that means, Jamie. If you could divulge, that would be amazing. But what I was going to ask you, Joe, is Is there anything? Is there a vehicle that you're going to put it in yourself? Have you got any electric hobbies yourself that you're working on other than the cell guard? I know it's difficult because I'm sure you've got quite a lot going on.
I don't, part of trying to, as I'm sure some of the people watching and listen to this, if you run your own business, most of your money goes back into that, particularly early days. I mean, there's tons of stuff I'd love to do, but right now I've got to spend it on this kind of thing, and see where it goes. So yeah, I'd love to have the time and the money to go and do loads of stuff. But I mean, one of my dreams is to earn enough money, and this is just a complete pipe dream, but to go back and finish Bloodhound. That is what I would love to do. But I mean, that's millions of pounds away. So, but yeah.
Well, if you've got a focus, it's just building the plan to make it happen, isn't it? I suppose.
Yeah, I mean, you've got to be.
Do you drive an electric car yourself?
No, I've got a Ford Focus, a 1 litre Ford Focus.
Ah, the 3-cylinder turbo.
That's it. They actually sound
I'm no stranger to a 3-cylinder turbo. I had a Daihatsu Charade GTTI back in the day, so know them well.
Yeah.
The old 1 litre 3-cylinder turbos.
I'm impressed about what they can get out of a 1 litre in terms of it sounds all right and it doesn't feel that slow. It seems all right.
No, that's it. So you mentioned, and I think I missed it because again, there's a little bit of delay. So apologies everyone for the delay here. But did you say that you can't buy single cell guards at the moment? What is the buying process for yourself?
You could just go to the Felton website and buy one from there. You can get individual ones. Yeah.
Okay.
Yeah.
Brilliant. Well, I'm hoping that there's a few more potential outlets that would be interested. Have you touched the American market with it at all, other than through Felton?
Yeah. In fact, they're one of the bigger markets for us at the moment. Yeah.
No, good stuff.
I've
got no idea what
What?
Can your sensor tell when the eco boom is going to blow? What's an eco boom?
Oh.
I feel like I need to look that up. But what I'll do in the meantime is I'll add this to the stage. So this is the Metis Engineering website, which has got the cell guard on there. Have you, with Metis Engineering, have you done anything else in terms of components? I know we were talking about the future of other sensors that you're doing, but is there anything that you've done in the past?
Yeah, so at the top there's our R&D sensor range, but that's kind of targeting more low volume vehicle manufacturers. So
okay,
if you there you go. So we've got a range of different sensors there. You've got a high data rate GPS, so that's 50 hertz position rate. So if you're moving quickly, then you might want to have more position fixes so that, let's say you're analyzing your path, it's less what you would call pixelated, if you like. It's more, there's more sample points. There's IMUs on there and attitude heading reference systems type stuff. That's for vehicle dynamics, and there's a dead reckoning sensor on there as well. And our original R&D version of this sensor. Yeah, we should update.
Looks like you work with Monroe.
Yeah, they've put some in there. Perhaps,
I see Monroe there. That's good to see. Well, I'll tell you one question that I did have, and I don't know if I thought it was quite a good question. I kind of gave myself a thumbs up internally for this one. It could be completely off the case, but with battery chemistry changing from NMC to LFP to sodium to solid state, that must affect whether how how effective this particular sensor is. How does it affect it as the chemistries change?
Yeah. So I would kind of flip this one around slightly. It's more to do with how safe the batteries are and what the driver is from the manufacturer into putting these kind of systems in. Now, the cell choice that people pick, NMC, LFP, maybe sodium, maybe solid state in the future. Like any kind of, I suppose, product or engineering thing, they each have their own benefits, like positives and negatives. NMC, high, power density, but slightly more volatile in terms of setting on fire, but you're going to need them for performance vehicles. LFP, less energy dense, a bit safer, but as people are finding out with LFP, although thermal runaway is less likely, you're still going to get a load of smoke. It produces a lot more fumes, and those fumes are poisonous and can essentially. So that's what the LFP thing is. So LFP, even if you're putting LFP in your car, it's going to be safer in terms of setting on fire, but it can still get to the point where it's going to off-gas, smoke a load, and produce noxious fumes. So people are still interested in putting this sensor inside LFP packs because of that. In terms of the sensitivity between NMC and LFP, the response is both pretty good. I mean, the gases, although albeit differently, the sensor can pick up various types of gases, so it doesn't seem to be really affected by it. In terms of response and performance. Sodium, I can't really comment on. Solid state, yeah, I mean, I suppose once people talk about solid state, if they manage to produce a cell which is never going to set on fire and never going to have issues, then yeah, maybe the detection of off-gassing is no longer needed, but the other parameters still will be. So we just switch the sensor or reduce or produce one which doesn't have that particular feature, which is the off-gassing. Bear in mind it has all the other features. I think also the rate of change of the market, any market is going to change, right? And you have to adapt to that. So the NMC and LFP technology, if you look at the numbers of cells produced, I think there's still the vast majority of cell chemistries that are out there and will be out there for the next 2, 3, 4 years. So yeah, things will change, no doubt. That's the way it is, isn't it? We're driving EVs, I suppose, but and you have to adapt to that. But there is a rate of change, and you can adapt. So yeah.
I've now worked it out, and obviously Jerome's confirmed it. EcoBoom, obviously EcoBoost engine. They're not a very reliable engine. From what I hear, it's a bit of a
Focus.
From what I remember, it's a bit of a throwaway engine. It's very difficult to repair from memory. In my old motor trade days, I remember hearing this. EcoBoom. There we go.
EcoBoom.
You learn something new every day. I've never heard that phrase, but I love it.
I'll know it. I'll know it when I hear it. I'll know it when I hear it.
Well, I don't think it's a physical boom, but I could be wrong. So, are there any other applications other than battery packs that this sensor can be integrated into the cell guard sensor?
The answer is we're developing one for HVAC systems. So that's for again CAN based, so targeting vehicles, so cabin air quality and things like that. So there are kind of spin-offs you can use this for. But I mean the market for EV battery packs, we're also looking at energy storage, which again is obviously battery packs, but that's
you did
nothing to do
with
which is potentially an even bigger market than EVs, so that's something else we're hoping to push into.
No, because I recently have heard quite a few horror stories of battery storage, not the best quality battery storage, and it's in your house, and that's where you sleep at night, and having that early detection. I mean, how easy is it to retrofit a battery pack that you're getting cheap from China, you know?
Yeah, I mean, it's a CAN-based sensor. If you set it up, the thing is, I think there's that barrier to entry, which is familiarity with using CAN buses, which I think, which is why we generally tend to target like integration at the build point, because I suppose more people are going to know, they're going to know, the manufacturer going to know about it. CAN, I suppose, in the automotive can be, well, if you're playing around with your own vehicle, it's actually quite hard to get the CAN definition to understand what all the data means on the bus. And a lot of the time that's the struggle. So it prohibits people from playing around with stuff. So I guess that's why we target manufacturers, OEMs, that kind of thing. But yes, it's just similar to the battery packs. They EV battery packs, they use the same technology. They'll use CAN-based comms a lot of the time in these energy storage platforms. So yeah, hopefully relatively easy for them to install at the design point. I mean, if you're a hobbyist and you know about this stuff, then yeah, sure. But the bigger market we see for us is obviously manufacturers. Yeah.
Is there a way of, I mean, I'm talking off the top of my head here, but is there any way that you could have a retrofit device, so you have the sensor and have something that enables you to put it a bit like this might be completely pie in the sky here, but a bit like a smoke alarm, so you can pop it on a battery and it can, I suppose it's got to be inside, hasn't it, really? Or is there any way that you could plumb it in somehow to retrofit it on something existing? Because I think
you can, and that is something that we're hoping to release a version of it this year, which is something similar to that. But yeah, I suppose for me, I suppose I want the product to, if I'm, we're a small company, so dealing with technical questions, it would be very hard for me if I opened up to the public, because the amount of technical questions I would receive would be very hard for me to respond to in any timely fashion. So that again is why I've looked into integration at the point of build, because they're making loads and you're only dealing with one person to do that. So yeah, you can add this on and do it yourself, but also the engineering, when I say engineering, the installation, you ask me questions, so where do you install it? How do you get the repeatability? How do you, those kind of things. My worry would be that somebody would just put it somewhere wrong and it wouldn't work at the time and they'd need it to work, if you see what I mean. So there needs to be, I feel, again, it's something I'd like to move into, and hopefully we do. But yeah, I mean, that's kind of my thoughts on it at the moment. Maybe I'll open up to it a bit more, but yeah.
Okay. Zoe's asked, can you integrate it into a non-CAN bus vehicle?
Yeah, if you so at some point with it, if you want, there's a digital eye on it which you can use to turn on something at a certain threshold. So when I say that, imagine the unit detects there's a cell vent. Well, you can use that pin on the sensor to turn on a relay or a light or anything really. But at some point, you will need to have CAN communications with the sensor to tell it what that threshold is, to set it up so it triggers. So although you can use it without a CAN bus, at some point you would need a CAN bus to set it up, if you see what I mean.
Okay. We've got a couple more here. Another one from Lars, been hot tonight. Is the CAN ID end user changeable?
Yeah, the CAN ID and also the CAN bus speed is changeable, it's configurable, yeah.
Perfect. And got another one. They're coming thick and fast again. Most DIY conversions involve some integration with CAN system these days, and I'm sure Ralph will be incorporating CAN-based systems on the TVR. Yes, I'm sure he is.
Yeah, it's hard to
in a couple of weeks. Was it on the 20th?
Hard to in this. It's hard to steer away from these digital communication buses. In these days, it's The benefits, I mean, they're just,
no, absolutely.
I like them. I mean, obviously, I use them a fair bit, and just the reduction in wiring is is just attractive to start with. So yeah.
No, definitely. Jerome makes a really good point, who, funnily enough, he's not on next week. He's on the week after, Chris. So it'd be great to speak to Jerome on the live. This type of product that makes you wonder why no one else did it before. Yeah, I completely agree. Absolutely. Yeah, spot on there, Jerome. And well done for Joe for, jumping on it.
Thank you.
If you're using something like Zombie Inverter, you'll have CAN comms between us, the BMS. Yeah, absolutely. What's Zoe saying? Oh, less wiring saves cost. Well, this is why, Tesla Cybertruck, they've gone 48 volt, isn't it? Because they can reduce the amount of it reduces the amount of current, doesn't it? Which means the wires don't have to be as thick, so it reduces weight.
So usually, so it's the other way.
Right?
So if you increase the voltage, you'll reduce the current typically.
Voltage.
But they might have gone for 48 volts.
That's what I meant. I knew what I meant.
They might have gone. Yeah, I've got this habit of being really annoying, so don't worry about it. But yeah,
no.
they might have
I need you on my side all the time.
They might have moved to 48 volt modules, sub modules, because obviously that's at the legal. That's beneath the legal kind of what's considered. Is it high voltage or medium voltage or something? But anyway, the point at which you're going to hurt yourself from an electric shock. That does make sense.
No, that's great. Do you know what? I am fresh out of questions. I'm on board. I definitely want. I was going to say one. I need two. So Joe, I'm very much looking forward to speaking to Ralph to add to his woes. If anybody has got any more questions, I'll just do a quick sum up. But if anybody's got any more questions for Joe and Selgard, and whack them in the comments now. I just want to say, first of all, thanks everyone who's asked questions and commented. It really, really helps. Please like and comment, like the video as well. That really helps. Like I said earlier in the conversation, we've got Chris Hazel from Felton, formerly Zero EV, on next week, which I'm really excited about. So if anybody's got any particular questions or subjects that we want to focus on, because we're going to try and steer away from talking about Felton, because I think Chris does talk about that a lot. So I think you'd like to talk about maybe a particular subject. There's plenty of subjects when it comes to EV conversions and modified EVs. And if you're not careful, we'll probably start talking about Japanese cars, because me and Chris like a bit of the Jap car action. So that's what's happening next week. Very excitingly, got a few videos coming through. Yesterday, I put a video out which was about the battery degradation on the Tesla Model 3 that I've got rusty. So check that out. I'm probably going to do another battery degradation test on my Tesla Model 3. Mainly because the miles are racking up now. It's done 95k, but also we're going to try the other method of testing the battery, which is the Tesla way instead of the Scan My Tesla app. So yeah, no more questions. So Joe, thank you really so much for giving us an hour of your time to talk about Selgard, because like Jerome summed up, this product is, I think it's a massive game changer for the EV conversion world. And, the sooner the OEMs adopt it, the better, as far as I'm concerned. So, yeah, thanks for joining us and explaining it. And, if you've got anything else that's coming out from the selection of bits or any updates, please share it with Chargeheads. And if you haven't, go and check out the electric TVR conversion. It's a bit like the Binky project. It's a never-ending.
I will. Project. I'll look at it.
But, thanks again, Joe. Thanks for everyone for listening, and we'll see you next week.
Thanks for having me too.
Thanks, Joe.
Bye-bye.
No worries. Thanks, Joe.